everyone, this is Manoj Yadav and you are watching Mechanotherapy. So guys, in our previous lectures we studied about the various types of supports, various types of loads and various types of beams. Now in this lecture we will discuss how to determine the value of support reactions. Okay, so as we have already discussed that the value of support reactions can be found out by using the equilibrium equations. The equilibrium equations are three. First one is sum of all horizontal forces must be 0, sum of all vertical forces must be 0 and sum of all moments must be equal to 0. So by using these three conditions of equilibrium we will determine the value of support reactions. Now let's take some numerical examples. Suppose we have a beam which is loaded by 20 kilonewton force. Now suppose this distance is 1 meter and this distance is 2 meter. A point, B point and C point. So this is the problem and now we have to calculate the value of these support reactions. So our first task will be to draw the free body diagram of the beam. That is, we will remove these supports and in place of these supports we will take the reactions and draw the diagram. So that diagram will be the free body diagram for this beam. Now you can see that this is a simple triangle, that is a simple support. In case of simple support we take only one vertical reaction. Now since the reaction is acting at point A, so we will give it the name RA. Now similarly at point B we have the roller support. In case of roller support we will have to take one vertical reaction. So the reaction is acting at point B, so we will give it the name as RB. Okay. At C point this load of 20 kilonewton is acting. 20 kilonewton. Now this distance is 1 meter. This one is 2 meter. So our first step is completed. We have drawn the free body diagram of this beam. Now we will apply the conditions of equilibrium. You can see the first condition of equilibrium is sum of all horizontal forces must be 0, that is sigma Fx equal to 0. Now in this diagram you can see there is no horizontal force. All the three forces are vertical. So this condition is already satisfied. Sigma Fx is already equal to 0. Now we will apply the second condition, sigma Fy equal to 0, that is sum of all vertical forces must be 0. So when we make equation for the vertical forces, the upward forces will be taken as positive and the downward forces will be taken as negative. This is a sign convention for these reactions or forces. So we will write the equation as Ra plus Rb minus 20 equal to 0. Sum of all vertical forces plus Ra plus Rb minus 20 equal to 0. So we can write it as Ra plus Rb equal to 20. This is equation number 1. Now we will apply the third equation, which is sigma m equal to 0. Sum of all moments must be 0. Now we try to take the moment about those points at which we are having the number of reactions. Okay, so we can see that one reaction is acting at B and one reaction is acting at A. So either we can take the moment about A point or we can take the moment about B point. So when we take the moment about A point, the moment of RA will become 0. Or if we take the moment about B point, then the moment of RB will be 0 and we will get the value of RA. So we try to take the moment about those points at which we are having the maximum number of unknowns, so that those unknowns can be eliminated and the value of one reaction can be found out. So let's take the moment about point A. So we will have to write sigma m A equal to 0. Okay. So this is the process. You will have to write that point about which you are going to take the moment. So if we are going to take movement about a point, assume like this. This is a point, and when RB will act in upward direction, it will try to rotate the beam in anti-clockwise direction. So anti-clockwise movements are taken as positive. So the movement will be RB multiplied by distance up to point A, that is 3. Now this 20 kilonewton load will try to rotate the beam in clockwise direction. So the movement will be taken as negative. Movement will be force multiplied by perpendicular distance up to point A, that is 1. This is equal to 0. So in this way you can find the value of RB as 20 by 3, that is 6.67 kilonewton. Now once you have calculated the value of RB, you can put this RB in this first equation and you will get the value of RA. So RA will be equal to 20 minus 6.67, that is 13.33 kilonewton. So this is the process by which we can find out the value of unknown reactions in case of simply supported beam with point load, or any type of beam in with point load. Okay, so the steps are clear to all of you. I think first of all we will have to draw the free body diagram, that is we will have to remove all the supports, and in place of these supports we will have to draw the reactions. Now once we have completed this first phase, then we will start the making the equations. First one is sigma fx equal to 0, sum of all horizontal forces 0, then second one sum of all vertical forces equal to 0, and third one is sigma m equal to 0. So by using these three conditions of equilibrium, we will get the value of RA and RB. Now you must remember the sign convention. When we make equation for sigma fx equal to 0, the forces acting in positive x direction will be taken as positive, and forces acting in negative x direction will be taken as negative. Similarly, in case of sigma fy equal to 0, when we will make equation for sigma fy, the vertically upward acting force will be taken as positive, while vertically downward acting forces will be taken as negative. Now the convention for movement is anti-clockwise movements are taken as positive and clockwise movements are taken as negative. So this is the sign convention for movement. By using this method, we can find out the value of reactions in each and every beam. Thank you everyone.